is when we use calorimetry and the mole together. Treat them just like geometry. Start with the calorimetry if you have all the parts. End with it if part of the calorimetry is in the answer. You can see this journal question here, how many grams of propane were used if it's heated from this much water, etc. So what we've got here is we've got our molar calorimetry question. And let's do this. We want to know the grams of propane that is combusted, so we need to get a quick equation. So let's go get a quick equation. Propane is C3H8. We need to burn that in oxygen. It's going to give us CO2 and H2O. And if we take a look over here, we have our heat here. It is negative, so it's at the end. 220, missed a 2. 2220. Mistakes happen. You know something? I'm actually doing this 2 ahead anyway. Let's try that again. In the end, you don't want to put the heat until you're done balancing anyway, so I'm getting ahead of myself. So let's balance this first and then go there. Okay, 3 of these, 4 of these, and that gives me 6, 10 oxygens, so 10 oxygens. Okay, now I should go and put my heat in after I'm done balancing. Okay, so since we have the mass of our water, we know the specific heat of water, and over here we have got the temp change of water between this. So we're going to take the 58.4, we're going to subtract the 12.1 degrees Celsius, and this is going to give us our 46.3 degrees Celsius, which is our delta T. So since we have, sorry about that, it was the bell. Since we have all of the pieces of our calorimetry for the water, we want to do our calorimetry of the water first. So I have got my mass, which is 250 grams, times my specific heat, which is 4.184, times my temp change, which I just calculated over there, as 46.3 degrees Celsius. So I calculate that out real quick, and I get 250 times 4.184 times 46.3 equals. So this is telling me that my heat is going to be, and I want to just keep this raw for now, 484, basically 30 joules. Now, I want to know grams of propane, so I need to take this joules and I need to put it into an equation. So I'm going to take those joules. I'm going to, first off, I'm going to take it so that joules to kilojoules, because up there is kilojoules. So there's 1,000 joules per kilojoule. And then I'm up here, and I'm going to do my stoich step, where I'm going to take my kilojoules down, and I'm going to change that into moles of propane, my C3H8. 1 mole for 2220 kilojoules. Then I'm going to times that sucker, taking my moles of propane down to grams of propane. For every 1 mole, I gotta calculate these grams, I don't know this off the top of my head. 12.01 times 3 plus 8.08, 44.11. 44.11 grams. So I take that joules I have, divided by the 1,000. divided by 2220 times 44.11, and I will then get how many grams of propane burned. And I look at the problem. I've got 4 sig digs, 333, so I'm going to go with 3. So I've got placeholder, then 1 sig dig, 2 sig dig, 3 sig digs, grams of propane. Like that. So I started with my calorimetry because I had every step. Then I converted it with moles using molar heat. And that's how that goes.